Algorithm. Algorithms are procedures for solving problems. The procedures are repeated a finite number of times, and processing is completed. There are many algorithms that produce the same results. However, it is necessary to consider things like efficiency, reliability, understandability, and the affinity for the data structure when selecting an algorithm. There are many processing algorithms. However, we will try to deepen our understanding of the sort and search algorithms in this section. One. Sort. Sorting means rearranging multiple data items in ascending or descending order using a key item. The data to be sorted may be represented in a data structure such as an array, list structure, or tree structure. However, here we will explain an example where the data is sorted in ascending order, using an array. A. Exchange sort. Two adjacent data elements are compared at a time, and then swapped if they are in the wrong order. Pass through the list is repeated until no swaps are needed. It is also called the bubble sort. When n, the number of data elements, is very big, the second power of n to the power of 2, becomes very big in comparison to n. So the number of times the key is compared can be thought of as being proportional roughly to n to the power of 2. B. Selection sort. First, the smallest element in the data elements is found and exchanged with the first element. Then, the second smallest element is found and exchanged with the element in the second position. This is repeated until the last element of data is checked. When n, the number of data element, is very big, the number of times the key is compared is proportional roughly to n to the power of 2, just as in the exchange method. C. Insertion sort. The insertion sort works by taking the data element one by one from the second element, and inserting it into a correct position so as not to change the sequence of the data elements remaining on the left. Number of times of key comparison. The key comparison is done the same number of times as the exchange method and the selection method. However, in the insertion method, the key comparison is finished when the insertion position is found. When the insertion position is searched for the k-SU data, if the maximum k1 times, minimum 1 time, or the exchange of n elements of the data occurs at the same probability, the key comparison of an average k/2 times occurs. When n is very big, the average comparison times of the key are proportional roughly to n to the power of 2, just as in the selection method and exchange method. D. Other sorting methods. Various methods to improve the basic sorting methods described above have been researched. There are sorts, such as the quick sort, improvement of the exchange sort, heap sort, improvement of the selection sort, and the shell sort, improvement of the insertion sort. Let us look at the quick sort. First, we choose the number in the center of the data elements as a pivot, and then split the elements into two parts, one with elements larger than the pivot and the other with elements smaller than the pivot. Recursively, we can repeat the algorithm for both halves of the original array. Two. Search. Search means looking for specified data, called a search key, from among multiple data elements. The data to be searched may be represented in a data structure, such as an array, list structure, or tree structure. However, here we will explain an example that uses an array. A. Sequential search. The search key is searched for from the top of the data in order. It is also called a linear search. Number of times of key comparison, when it is certain that the search key exists in n elements of data, the minimum number of times of comparison is 1, and the maximum number of times of comparison is n-1. It follows that the average number of times of comparison is n/2. B. Binary search. The data to be searched is sorted beforehand. The region to be searched is divided into two parts, and the search key is searched for in this method. Number of times of key comparison, when it is certain that the search key exists in n elements of data, the search target region only half the previous size is searched at a time. When there is one last element of data remaining, the search key has been found. When dividing the data in half, truncation is used, so it is actually terminated when the numerical value is greater than 1 and less than 2. The number of times of comparison is assumed to be k. The average number of times of comparison is the integer k that fulfills the expression a. The maximum number of times of comparison is k plus 1. C. Data storage and retrieval using hash method. Both the sequential search and the binary search have poor efficiency, depending on the value of the search key. In the hash method, the storage position is calculated from the data value itself, and the search check and access is done using that calculated value. Because of this, the search time is not influenced much by the search key. In the hash method, a function is applied to the data value, and a single numerical value is calculated. That value becomes the storage position. The value is called the hash function. In this method, there are cases when the same value, called synonym pointing at the same storage position, occurs due to the hash function. It is necessary to think about how to deal with this. One measure to deal with this is to manage the storage by linking the synonym data using pointers.